I'm gonna like ask them every day if they're going to talk. You're gonna talk? I'm gonna like press her to go to talk and just guilt her into it. Okay, the good news is really, with them being on today, we're not really learning a new skill today, we're just learning the vocabulary that goes with it. But all those things that mean find the slope of the curve, or find the slope of the tangent line, we're going to add even more words that mean the same thing in there. So I wrote on your paper here, and this is a quote from your book here, that the derivative was the 17th century breakthrough that enabled mathematicians to unlock the secrets of planetary motion and gravitational attraction of objects. Like, amazing. Think what you've done in your life. We did not discover this, right? Alright, so the slope of a curve at a given point, the slope of the tangent line, the instantaneous speed, the instantaneous rate of change, all of those mean the same thing as saying the derivative of the function. So now, instead of having to say, find the slope of the curve at the point, I can say find the derivative, and it means do the same thing. So it is just this notation, right? So I'm going to write it myself. It's like f prime of x, probably 1, times f prime of x. So that's the notation for derivative. And the way we do that is the same way you did on your last test, which is this lovely limit definition. So we can say that the derivative, or f prime of x, is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Provided that the limit exists. So far, almost everything, I think everything has had a limit. Right? So far so good? Nothing new. Just a new word and a new little way of writing. So, if the derivative exists, we say that f has a derivative. Also, we say it's differentiable, which is an awfully big word. That should be on some of this. Progress like that today, and elementary is the bonus word, and we practice it today, and I have a little app on my phone that I can put all those fun words in. And like I put the list in it, and we can practice in it, and you can say you can do ace it, and you have to keep spelling it so you get it right, and it shows you how many times you get wrong. You got elementary wrong 5 times. So a function that is differentiable at every point in its domain is a differentiable function. So if it's a differentiable function, that means you can take its derivative at any point. And we're going to talk about what isn't differentiable at some point. If it's not differentiable, do we say non-differentiable? I'm trying to make longer words. Okay, so if I said find the derivative of x cubed, that's the same as on the last test if I said find the slope of the curve of x cubed, which just means do the limit thing, right? Only I thought we could be exciting here and do a cube instead of a square thing. So notice they didn't tell us at what point. So we're just doing the generic slope for like any point on the graph. So we're not plugging an actual number here. So f prime of x, I'm going to write it all out. The limit as h approaches 0 of f of x plus h minus f of x all over h. And my function here is x cubed. So I would get x plus h cubed minus x cubed all over h. So how do I do x plus h cubed? Just x cubed plus h cubed? No. Right? It means that there's 3 of them. It's like x plus h times x plus h times x plus h. So we could like FOIL it and then multiply again. Or, do you remember the little Pascal's triangle? Oh, remember that fun game? Like 1, 1, 1, 1, 2, 1. What's the next row going to be? 1. If you add these two together to get the next one, each row gets more. So I think, if I have to cube this out, I think it's easier to do this than to FOIL it, like for me. But if you'd rather, you can do x plus h times x plus h times x plus h again. I always give you this one before I teach you the shortcuts to make you appreciate the shortcuts in life. The shortcuts for derivatives, because if you did not know the shortcuts for derivatives, every time you had a power bigger than just x squared, you would have to do all this work to do this. It'd be awful. So, if I do the Pascal's triangle, remember these are my coefficients, and then this x would start with x to the third and go down, and the h starts with no h and goes up. If this looks like x cubed plus 3. And then what would my letters and exponents be? Right, because the x is going to go down by 1, and the h is going to go up by 1. Since the x comes down again, I just have x, and then that becomes h squared. And then I end with 1h cubed. The good news is that x cubed is the worst that you see on your homework, so you don't have to do like which is a bit solid. But remind ourselves about this, right? Questions on where I got that? So now I'm going to do just like we did on the test that you did so well on these questions. These questions, that wasn't me being mean. We really did do well on these questions. Like you all like got that question. Right? So I'm going to factor my h out. I would get 3x squared plus xh plus h squared. Again, that's so that I can actually take the limit. So then when I plug in 0 for h, I'm just going to get 3x squared because the rest of this goes to 0. That equals the derivative of that function, which represents the slope at any point on that graph. So now I could say, like, at 0, what is the slope? And you could plug 0 in there, and you would say the slope is 0. What's the slope at 1? Well, 3 times 1 is 3. So at 1, the slope is 3. So this is like the formula for every slope of that curve, and depending on the point, then the slope changes. So that's the difference between slope as an equation and slope as at a specific point. Questions about that? So there's also this another way that we can look at the definition of derivative that sometimes is a little confusing. And they call it derivative at a point. And basically it's just using a specific point A in this. So Sabrina was showing me on one of the homework things, like it showed her, like in the show me example, it used this equation, and I was really mad because this is in chapter 3 and the homework was from chapter 2. But in the show me how, it used this equation, and she's like, why is this different than the equation you taught us? Well, this is if they give you a point, and I'm going to kind of show you a little proof of this in a minute. But if I have the derivative at a point, I can say that instead of taking the limit as x approaches h, I can take the limit as x approaches a, and I can just take f of x minus f of a over x minus a. And it just makes things a little bit easier sometimes. And it only works if you have a specific point. So, let me see if I can write you a problem. I never questioned this definition, so I'm just going to throw this out there, and then you can tell me if you've had the same thought. But Sean Logue, do you remember Sean Logue? He's been a while ago. He was in my calculus class, and when I gave this definition, he was very upset about it because he didn't understand how on the bottom I could have x minus a when x equals a. So that's really like subtracting it from itself, and like I don't even know, like it just went like I'd never had that question before. But he was really upset about this, and so that's where this little graph came from, as I was trying to show him that A represents a point on your graph. So like if this is A, then up here, this is the point like A, F of A. So it's not really like, yes, A is the X value, but it's not the same as this X value. So it's kind of like if this was another, hold on. And maybe you're like, I never would have questioned this until you bring it up. But because he was so upset about it, like I'm pretty sure we spent the rest of the day today arguing about this definition right here. Because he was just very upset about it. You should read your book. Yeah, okay, that's what I was gonna do. They actually put the A first and the X second. I don't know that it really matters if you do the order there. But let's just pretend I put X here. So up here, this would be the point like, oh, that's not good. This would be the point like X, F of X. So pretend that this is like, so if I was going to do the slope of the secant line, right, I would just subtract the y's over subtract the x's. So I would get f of x minus f of a over x minus a. And that would be the slope of the secant line. But just like our other definition where we talked about h being this little small value, if we think about x approaching a, so if we think about these 2 points getting closer and closer together, then eventually that secant line will become the tangent line. So it's still that limit idea, but you just don't have this extra variable of h in there. But x and a are actually like 2 different points on the graph, but it was just this right here, just kind of threw them off. And then when he said it, everyone else was like, oh yeah, I thought the same thing. I was like, okay, apparently it's an issue. So that's why I wanted to show you the picture. But I just want to show you how this, doing x cubed especially, if you're doing it at a specific point, how this definition is a little less algebra. So like if I was going to do this at 2, the notation here would be f prime of 2. That means the derivative at 2. And so maybe this is where the confusion is, because do you plug 2 in for the x spot, or you plug 2 in for the a spot? The a spot, because it's where x equals a. So this is your a value. This is like your point. So this is your point. You leave x in the problem. So you're going to do f of x minus f of 2 all over x minus 2. Oh, I see. Yes, thank you. It's the limit as x approaches a, so it's the limit as x approaches 2. I can do that part. The limit as x approaches 2 now, because we're trying to get the a and the x values together. So we want the x to move up to 2, right? So now, as x approaches 2, we have just x cubed. And then if I plug 2 into that problem, that's just 2 to the third, which is 8, all over x minus 2. So we don't have to multiply anything out this time, but another thing comes up here. A perfect cube minus a perfect cube. Do you remember how to factor that? Oh my gosh, look at all this algebra coming back to our life. You have a perfect cube minus a perfect cube. Remember you just like a minus b, and you have this trinomial over here, where it's a squared plus a plus. And if it's a cubed plus b cubed, you just switch this side with this side. So maybe you're like, I'd rather just multiply it out on the last one. But I always think it's good to remind ourselves of the algebra we're supposed to remember. So that means this is x cubed minus just 2 cubed. So a is x and b is 2. So that's going to factor into x minus 2. And then x squared plus x times 2 is 2x plus 2 squared is 4. So if you can factor that, then we can cross out those x minus 2's. So now remember, we're not doing h go to 0 now. There's no h in this problem. We're just going to plug 2 in for x now that we crossed that out. So the limit as x approaches 2, I just get 2 squared plus 2 times 2 plus 4. 4 plus 4 plus 4? Get a slope of 12. I don't really care which definition that you use. There's some on your homework today that might say, like, use this one or use the other one just to practice. But when it comes to test time, like, I just care that you can do it one way or the other. A lot of people like this one because it's less algebra involved, like there's less spoiling out with an H in there. I've seen on the AP test, like a multiple choice question, like the one that we did on the test for chapter 2, where like they give you different things and you have to recognize that it's a derivative, so you have to recognize that this form is a derivative also. That's the one thing that I think shows up the most. Just to show you really quick, if we went back to the one we just did over here, the answer that we got was 3x squared. If we plug 2 in there, just to show you, we also get 12 that way. Like, it's the same thing. That's why I don't care which one you do, but I just want to show you this one, especially since it was in this. Alright, now I just got a lot of vocabulary for you. Alright, so if we say differentiable at x, that's the same as saying that the derivative exists at that point. So differentiable kind of means that the derivative exists there, or the slope of the tangent line exists there. If we say that it's differentiable in an open interval, then it's going to have a derivative at every point in that interval. And we're going to talk more about that tomorrow. We're going to talk about the graph of a derivative. Like if we have a function, what does this graph look like? Issues that might come up when we're graphing a derivative. And then there's a lot of ways to write out derivatives. And so I've kind of given you all the ones I could think of. Really important when it comes to homework and tests. Really important when it comes to AP stuff, of knowing when it says do this, that it means just find the derivative. And so the one that I use the most are the first two here, like f prime of x, and I just kind of wrote how you say it, f prime of x. F of x is the same as y, so you can also say y prime. I feel like my prime's going on. This is just y prime. Also used a lot is dy over dx. And think about slope is like the change in y over the change in x. And so instead of talking about like the change in, or sometimes we say delta y over delta x for slope, we just change that to in calculus. So we say it's the derivative of y with respect to x. So you can say all of those when you're writing derivatives. You can say the derivative equals. Something that you'll see a lot when they ask you to take a derivative, and it always throws people, is that they'll say d over dx of a function. And again, think about y is the same as f of x, so that's interchangeable there. But this just means like take the derivative of the function. Yeah, the derivative of the function at x. And yes, with respect to x matters, so that's some point we'll talk about. One I haven't seen very often, but it's in my list of ways you can write it, is like a capital DX. Like, what does that even mean? I don't even say that like ever. I don't know. There's like multiple things. stuff. I don't know. I mean, but these four definitely show up a lot. These four. Let's go. Find the value of f prime of 2 for this function, and then I write the tangent line. Writing tangent lines, writing normal lines, still a huge part of what we're doing. So, because we're doing a point here, you have two options here. You can do the limit as x approaches h of f of x plus h minus f of x all over h, or you can do the limit as x approaches a of f of a, right? F of x minus f of a over x. You're going to use the same answer. So in this case, a is 2. So we could say the limit as x approaches 2 of f of x minus f of 2 all over x minus 2. And after all of our cubic stuff today, dealing with x cubed, I put x cubed, okay? So f of x is just 3x minus 7. And then if I plug 2 in there, you can either just do the whole thing, or you can just plug in 2 and then distribute. But 2 is, what? That's going to be 6 minus 7, which will be negative 1. But I'm subtracting a negative 1. So I'm just going to go make that plus 1. Are you okay with that? Again, you could write, like, minus 6 minus 7. That's another way to think about it. Again, compared to all the h stuff that we've been doing, this is why people really like this if you're taking the derivative at a point, because it seems like less room for error. Just some good old algebra practice here. So I can write that as 3 times x minus 2 over x minus 2. And then what happens? You just get 3 as your answer. So the derivative at 2 equals 3. Derivative just means the slope. Could have saved ourselves a lot of work here. Look at this equation. What's the slope of that equation? It's a linear function. So linear functions have a constant slope. So that's why when we got to the end, there's no x left in this problem, because the slope is always 3 no matter what x value you're at. And again, it's okay. I didn't want to know that, and then I knew you wouldn't do it, right? But you can still practice doing that. So the slope is 3. So instead of saying the slope of the tangent line, we can say this. And then just like we did on the last test, I could ask you to find the equation of the tangent line. So this is my slope. What else do I need to write in an equation for a tangent line? Yeah, the y value. So when I think of tangent lines, I need 2 things. I need the slope, which I found already. I also just need the y value, which is just f of 2, not f prime of 2. So if you have those 2 things, you can write your tangent line. And so 3x minus 7. So 3 times 2 minus 7 gives me a y value of negative 1. So I get y minus negative 1 equals my slope times x minus 2. And again, depending on what form they ask you to put it in, you could change it if you want. This is where, when we have textbook homework, I would say, check the back of the book. They write it in the intercept form, you put it in the intercept form. They write it in standard form, you put it in standard form. Well, now I can just say, I'll tell you. I could ask you to write normal lines again, because we're still doing the same stuff, we're just adding different notation. The new definition. Okay, so the homework is on that X file. But it is on there. we'll do more tomorrow, and tomorrow will be new. Like today was kind of just new notation with words. They might be that tomorrow we're going to talk about like graphs and it does become a little bit more complicated.